So, good morning, everybody. Myself, Acharya Vishwendra, and today I'm going to discuss the moment of inertia. So, let's start the basic worksheet. So, here is the level 1 worksheet for moment of inertia. So, the first question is moment of inertia is it's a tensor quantity. Next is what is result of moment of inertia? It is I is equal to mk square, where m is the mass, k is the radius of gyration, and I is the moment of inertia. Next are some basic questions based on the graph. So as we can see that I is proportional to m, so the graph will be a straight line. And if it makes an angle theta with the m axis, then tan theta is equal to I by m, which is equal to k square. Next we have three different graphs. So if the angles are theta 1, theta 2 and theta 3, then corresponding to the greatest angle, radius of gyration will be maximum. So this analogy we can draw from the graph. Next there is a question, there is a point mass m having coordinates x comma y, that means it is in the xy plane. We need to find moment of inertia about y-axis. So as you can see that distance from y-axis is equal to x. So Iy is going to be mx square. Next is moment of inertia about x-axis. It is equal to my square. Next is moment of inertia about z-axis. So using perpendicular axis theorem, we can say that Iz is equal to Ix plus Iy, which gives Iz is m into x square plus y square. Next is a question, there is a point mass of 5 kg. It has coordinates 1, 2. We need to find moment of inertia about x-axis. It is mv square y square. That means 5 into 2 square, which is 20 kg meter square. Next is moment of inertia about y-axis. It is mx square. So substituting the values, we have 5 kg meter square. Next is moment of inertia about z-axis, which is Ix plus Iy. On solutions, we get 25 kg meter square. Next, there is a question on equilateral triangle. 3 point masses are placed at the vertices of the equilateral triangle. And we need to find the moment of inertia of the system about x-axis. So I assume this mass is 1, this is 2 and this is 3. So moment of inertia of the system is I1 plus I2 plus I3. So if we calculate about x-axis, we can see that for mass 1, the distance from x-axis is 0. So its moment of inertia will be 0. For 2, it is also 0. So its moment of inertia will also be 0. Whereas corresponding to mass 3, if you see in this right angle triangle, this is going to be L root 3 by 2. So after substituting the values, we have I system about x-axis as 3 by 4 ml square. Similarly, if we calculate the moment of inertia of the system about y-axis, so same concept we will use, that I system about y-axis is I1 plus I2 plus I3. So point 1 is on the y-axis, that means its moment of inertia will be 0. Whereas for point 2, the distance from y-axis is L. So moment of inertia will be ml square. 4.3, the distance will be L by 2. So it will be ml by 2 whole square. So we have the resultant of all these as moment of inertia of the system about y-axis as 5 by 4 ml square. Next is we need to find moment of inertia of the system about z-axis, which is moment of inertia about x-axis plus moment of inertia of system about y-axis. So if we add these two, we get 2 ml square. Next is about the radius of gyration. So if we think about radius of gyration about x-axis, we have Ix as m system into kx square. So on substituting the values of Ix as 3 by 4 ml square and mass of system as 3m, we have kx as equal to L by 2. Next is moment of inertia about radius of gyration about y-axis. So we have Iy as m system into ky whole square. So after substituting the values, we get radius of gyration about y-axis as root 5 by 12 into L. Next we have dimensions of moment of inertia. So it is m1 L2 T0. Next question is SI unit of moment of inertia, it is kilogram meter square. Next is CGS unit of moment of inertia, it is gram centimeter square. So this is a basic worksheet on the concept of moment of inertia, and these are just made to make sure that you have good grasp over the fundamentals of the topic, so that ultimately you can cope up with the complex problems and can certainly produce desired optimal output. Thank you and have a nice day.